Yes, ma'am. Good afternoon, ma'am. I'm sorry to take the lectures at this time because I think usually you have your lectures by 1 o'clock, no? So this time, little bit advancedly, I'm taking the lectures by 12:30. Is it okay for you all without having lunch, joining in the lectures continuously? What was the lectures previously you had? Yes, ma'am. What was the lectures?
English, ma'am.
English. Then I think it's okay now to have the lectures by this time, no? Since you had the English lectures. So you can concentrate more on this, right? Are you all right? Are you all okay?
Yes, ma'am.
Yes, ma'am. Okay, thank you. So today we are going to cover the chemical properties of soil, right? So almost we have started to discuss about the soil physical properties, right? So what are the physical properties you studied so far?
Soil texture, structure,
Okay. Okay. What are
bulk density.
bulk density? Yes, soil density, texture, structure. Water content have you started?
Yes, ma'am.
Yes, ma'am.
Okay. So like soil physical properties, here we are mainly focusing on soil chemical properties. So why we want to study about the chemical properties? Do you have an idea? AG121? Can you please answer me why we want to study about the soil chemical properties?
Measure the soil pH.
Yes, soil pH. pH is one of the chemical property. What else? Why we want to think about it? What is the importance of studying chemical properties? Any others?
We have to know whether the soil is suitable for agriculture purpose.
Exactly. We have to know about whether the soil is suitable for the agriculture purposes or any other purposes, right? So here, the fertility status of the soil is important. Okay, then only we can think about the agriculture. Okay, if the soil is not fertile, so we cannot go for the agriculture there, right? So the in case of agriculture, plant growth and yield, and also the fertility status of the soil is very much important. Okay, so to know about these properties, so we have to study about the chemical property of the soil, right? Under the chemical property, here we were mainly focusing on soil colloids, right? What is soil colloids, right? Because the soil colloids are very much important for the chemical reactions, right? So here we will study about soil, what is soil colloids, and what are the types of colloids are there in the soil, and what are the colloidal properties, right? So these and these are the things we are going to discuss more here, right? And as we discuss here, the chemical properties of soil refers to the nature of chemical charges in the soil, because these charges are mainly important for the nutrient transfer from the soil solution to the soil colloids. So because of this nutrient transfer through the cation exchange reactions, the plant will able to take up the nutrients from the soil, right? Without the cation exchange reactions, the plant cannot take up the nutrients from the soil, right? So for this cation exchange reactions and all, the chemical charges are important. Okay, so these charges mainly depends on the organic and the inorganic constituents of the soil. Right? You know, the soil is comprised of soil organic matter, inorganic matter, soil water, and the soil air. Okay, can you remember the constituents of soil by volume basis? Anyone? Anyone please tell me what is the volume composition of the soil? 005. So those, yes, what are the volume composition of the soil with their respective percentage? 005. Can you please tell me? 003.
Yes, ma'am.
Yeah, tell me the volume composition of soil. If you don't
Soil,
answer, please there. Okay,
soil,
okay,
water, soil, air,
okay, okay,
organic matter,
okay.
inorganic matter.
Inorganic matter with the respective percentages. 004. Can you please tell me the percentage of each components there? Are you there? 004. If you don't answer the question, then definitely I will consider that you are absent for the class. Right? 054. So the what are the percentage of these compositions? AG054.
Yes, madam.
Okay.
Soil water 25 percentage, soil layer
Okay.
25 percentage, organic matter 5 percentage,
And
inorganic matter others 45 percentage.
Okay, so this organic and inorganic constituents together we considered as the solid materials. Okay, so mainly these chemical charges are depends on the solid materials like organic and the inorganic constituents of the soil, right? So again, these chemical charges are mainly influenced by the soil colloids. Right? So these chemical charges are influenced by the soil colloids. You don't have an idea about the soil colloids, no? So you may not have the idea about what is soil colloids, right? So as I said earlier, here mainly we are going to focus about the soil colloids, what it is, actually what is the soil colloids, and what are the properties of soil colloids, and also what are the types and the classification of the soil colloids. Okay, so now you have an idea about what is chemical property. Chemical property is the nature of the say chemical charges in the soil. This charges mainly depends on the organic and inorganic constituents of the soil. Okay, and in other words, the charges also influenced by the soil colloids. Right now, we are going to think what it is the fertility status of the soil. Okay, so mainly this fertility status of the soil is determined by the soil cation exchange capacity. Okay, so the cation, what do you mean by cation exchange capacity? Anyone? Anyone? Do you know what is the cation exchange capacity? So it is the ability of exchangeable cations present in the soil. Simply, this is the definition. Simply, ability of exchange or amount of exchangeable cations which are present in the soil colloids. That is, we call as the cation exchange capacity. Or else, we can tell that the ability of soil colloid that hold the exchangeable cations. Okay, if the soil colloid having the exchangeable cations only, so the plant can take up the nutrients by the exchange reactions. Okay, so for all these properties, the soil colloids are important. Okay, here again the soil colloids have high cation exchange capacity because the soil colloids having the more surface areas. Still, you may not have an idea about what is soil colloids. Okay? Now we are looking about why this chemical property is important. Right? We didn't move to the soil colloids still. Right? So the soil colloids have the high cation exchange capacity because of the high surface area and the charges. Right? So now you may tell that without the soil colloids, so the essential nutrients will not remove, will not be uptaken by the plants. Okay. Ultimately, what happens is it would removed from the soil by draining water, and ultimately it will move to the underground. Right? Understand? This is the importance of studying the soil chemical properties. Understand? Right. Yes. Simply, the soil chemical property is important to know about the fertility status of the soil, to study about the fertility status of the soil. Right? Here, the chemical property means it is the nature of chemical charges in the soil. So these charges mainly depends on the organic and the inorganic colloids. Right? So this inorganic and the organic constituents are made up of colloids. Right? That is the colloids. So if the soil colloids is present there, so it may have the high surface area and the high charges. Because of that, it may have the high cation exchange capacity. Right? If the cation exchange capacity is high, so definitely the availability of nutrients also high there. So the plant can take up more nutrients. Okay, it will protect the nutrients from the leaching. Right? So this is simply the importance of studying the chemical properties. Now we'll move to the soil colloids. What exactly the soil colloids? Right, we don't have idea about the soil colloids. Now we are going to study about what is exactly the soil colloids. Okay, so here we can tell that the soil colloids can be defined as the particles of soil with a diameter less than 1 micrometer. Okay, what is the diameter of the soil clay particle? You have already studied about the soil texture, no? Have you studied about soil texture?
Yes, ma'am.
Yes, classification, soil texture classification. Then what do you mean by soil texture then? What do you mean by soil texture?
The amount of slip particles, clay particles, and the sand particles.
Yeah, relative, it is a definition should be very clear, right? That is, the texture means relative amount of sand, silt, and the clay particles. So what is the diameter of the soil clay?
Less than 0.002 millimeter.
Yes, exactly. Less than 0.0002 millimeter. That means 2 micrometer, right? So do you think that all the clay particles are colloidal particles? By looking at the diameter of the colloidal particle. See here, what is the diameter of, I hope that you all can see my slides here, no?
Yes, ma'am.
Okay, okay. By looking at the third point here, so the colloidal particles, the colloid's diameter is less than 0.001 millimeter. So do you think that all the clay particles are colloids? You know the clay particle
No.
diameter. Yes, exactly. Not all the clay particles are colloidal particles, right? So the colloids means here, it is the active portion or the alive section of the soil, and it determines most of the physiochemical properties of the soil, as we discussed in the previous slides. Okay, it determines the cation exchange capacity, it determines the water holding capacity, and so many physical as well as the chemical properties. Right here, so this so that at the meantime, these colloids can be organic or it may be inorganic particle with a diameter of less than 1 micrometer or less than 0.001 millimeter. That means it is clearly says that all the clay particles are not colloidal particles. Understand? All the clay particles are not colloidal particles. Okay, so they are essential because charged ions on their surface attract soil nutrients when dissolved in soil water as positively charged ions. Therefore, the colloidal particles serve as a bank of nutrients. You know, the colloidal particles, it has the high surface area. Normally, we say that almost all the soil colloids are negatively charged, right? So, soil colloids are negatively charged. So, therefore, it may have the ability to attract the positive charge cations. Okay, so because of that, it may form the double layer. At the meantime, it can hold much of the nutrients by attracting the cations. For example, it may attract the calcium, magnesium, potassium, sodium, ammonium like cations. Okay, so these are the major nutrients for the plant. Understand? By attracting these nutrients, it can hold much of the nutrients in the colloidal particles. Okay, so here you can see the colloids are the sites where the essential elements such as ammonium, potassium, calcium, magnesium are protected from the excessive loss by the percolation via drain or the irrigation water. So if the soil colloid is, just imagine if the soil colloid is not present in the soil, what will happen to this nutrient? We say that the colloidal particles are negatively charged, so they may have the ability to attract these positive charge cations and call these nutrients with them. So if those colloids are not present in the soil, what will happen to these nutrients? Anyone? Shall I call the number? It is easy for me. Yes, 044 044. AG 044. AG 044. She is not there. She or he. Definitely, I will consider them as an absent, right? For the class. So if you have really any problem, you can tell me, right? 077.
Yes,
Zero double. Yes. Can you please tell me if the soil colloid is not present in the soil, what will happen to the nutrients? 077, are you there?
yes,
Can you tell me? If you don't know the answer, you can tell me. If you don't understand, you can tell me. You don't have idea? 077, you don't have idea?
it's not.
No idea. So here, what I'm saying is soil colloids. We are talking about the soil colloids, right? So the definition of the colloids, you should know any particles with a diameter less than 1 micrometer or 0.001 millimeter is considered as the soil colloids, right? So these colloidal particles are the active component of the soil. Okay, at the meantime, it determines the most of the physiochemical properties of the soil. Right? So another thing, these colloids are negatively charged. Okay, so if it is negatively charged, what will happen? So they may attract the positive charge ions, right? So because of the attraction force, negative charge can easily attract the positive charge ions. Therefore, they may hold these cations with them by protecting them from the leaching. Okay, so if the colloids is not there in the soil, so what will happen? Definitely this will leached out to the groundwater. So the plant will not take up these nutrients. Plant cannot take up the nutrients. Okay, understand now? 077 077. Anyone having doubts? So when it holds these kind of nutrients, when the plant needs, they can take up the nutrient from the soil colloids by the cation exchange reaction. Okay, we will study about the cation exchange reaction deeply. Uh, I think at the end of this session, right? Later we will discuss about it, cation exchange capacity. Now you should remember the term cation exchange capacity. I already told you about it, the definition, right? So these ions can be withdrawn from the colloidal sites and taken up plant roots. Okay, now we see the properties of soil colloids. Okay, generally we discuss about three properties. One is, who is it here? Yes, we will discuss about three main properties. It may have several properties, but here we will mainly discuss about three properties. One is size, surface area, and the charge, surface charge. Okay, these are the three major properties that we are going to discuss. Okay, again later we will discuss about the colloidal properties. Right here, in case of size, okay, this is just for the definition of the soil colloids. Okay, so size, in case of size, you know, the organic and the inorganic colloids are there. So we will discuss about these colloids in the classification of the soil colloids, right? Here just you know about the colloids. These organic and the inorganic colloids are smaller in size, right? Which means less than 0.001 millimeter or less than 1 micrometer. Okay, so they can only observed by the electron microscope. We cannot observe these particles by the naked eye. Okay, we have to use the electron microscope, or even we cannot see through the light microscope because it is the very, very small size here, right? And when you look at about the surface area, so it is a very small size. Because of this small size, it exposes a large amount of external surface. You know, the basically, if the size is very small, the surface area is high there, right? Normally, compared to the sandy soil, clay soil have more surface area. Do you agree? Do you agree to that?
Yes, ma'am.
Yeah. Surface area is high for clay soil than the sandy soil, right? Because of smaller size. So here you can tell the external surface area of 1 gram of soil colloid is at least 100 times more than that of 1 gram of coarse sand. Okay, because the basic thing is the size of the colloidal particle is very small. Because of that, the external surface area is high. Okay, some clay have extensive internal surface area as well. It is occurs between the plate-like unit that make up each particle. Here, you don't know how these colloids are developed, right? So when the colloids develop, there may be the internal surfaces, so that also may be considered as the surface area. So for some kind of clays, colloids, we will consider the internal surface area. For some kind of clays, we don't consider the internal surface area because it is mainly depends on the bond between the layers. Okay, so this internal surface area commonly exceed the external surface area. the surface charge. So as I discussed, minute colloids carry the negative charge, but some mostly the negative charge. Soil colloids are having negative charge, but some colloids they may have the positive charge for ions also, right? So due to this, hundreds and thousands of positively charged cations are attracted to each colloid. Because of this negative charge, it may attract the positive charge cation. Okay, so because of this attraction, this may form the ionic double layer. Here you can see this is the colloids. Here, this is the external surface. This is the external surface, and this is also the external surface. Okay, when you look at it closely, this one, here you can see this is the internal surface, right? Internal surface. It is the negatively charged. So because of this negative charge, can you all see this light?
Yes, ma'am.
Okay. Because of this negative charge, it may attract the positive charge cations like calcium, potassium, aluminum, hydrogen. Such kind of positive charge cations may be attracted by the soil colloids, and it forms the ionic double layer, positive and the negative charge. Understand? It forms the ionic double layer. Okay. Here, so this because of this attraction of positive charge cations, this gives the ionic double layer. Inner layer being a huge anion and outer ionic layer made up of loosely held cations attracted by the negatively charged surface. In addition, large number of water molecules are also associated with the colloids. So some of these water molecules are having cations. So these water molecules are important in determining the physical and the chemical properties of the soil, especially the water holding capacity, right? So though most of the colloids have a negative charges, some colloids have the positive charges as well, right? This is important, right? This kind of statements may come for your quiz exam as well. Multiple choice questions. Okay, most of the soil colloids are negative charge, whether it is correct or not. Such kind of questions you may expect for your quiz examination, right? So are you all clear about this ionic double layer? How it forms? How it forms ionic double layer? AG062. AG062.
Yes, ma'am.
Can you please explain me how the ionic double layer is formed? It's 4. Can you please? If you don't understand, you can tell me. Anyone having doubts? Anyone having doubts? Please tell me. AG060. Are you clear? 60. Yes. Are you clear? Who is this? Yes. You want me to repeat it? Yes, exactly. Wait. Here we say that the most of the the colloidal particles are negatively charged. Understand that? Understand that? Person, yes. If it is negative charge, what happens is it may attract some positive charge cations. Okay, understand here in the statements. Why the negative charge definitely attract the positive charge cations. Understand? So what happens is the inner layer it may hold much of the positive charge cation. Okay, it may hold much of the positive charge cation. At the meantime, in the outer ionic layer also, here, sorry, here in the outer ionic layer also, it may, so this negative charge may attract the positive charge cations like calcium, magnesium, aluminum, hydrogen, potassium, like cations may be attracted by the negative charge cations. Okay, still because of the size of this ion, still it may have the net negative charge. Okay, because of this net negative charge, again it may attract some positive charge cations. Okay, so in the inner layer part, so this may tightly held this positive charge at times. At the meantime, in the outer layer also, it may can hold some positive charge cations. Therefore, it may create the ionic double layer. Understand? Now, are you clear? Okay, good. So here also you can refer it. The ionic double layer, inner layer being acute anion, and the outer ionic layer made up of loosely held cations. Okay, here this is the anion and this is the cation. Okay, at the meantime, this forms the ionic double layer. Here, in the inner layer, it is tightly held anions, right? Because of the size of these cations is made loosely held. At the meantime, if it is net negative charges are there in the again net negative charges there, it may attract much of the positive charges. Okay, and it goes to ionic double layer. Okay, that's all about the properties, general properties of alkalis. Are you clear? Are you clear? Any doubts? Okay. Then now we'll move to the classification of soil colloids. Okay. So the types of soil colloids. Okay. Now, so far we discussed about. Sorry. What is the importance? What is chemical properties? And what is the importance of chemical properties? Right? We mainly discussed about soil colloids, what it is, and what are the general properties of soil colloids. Under that, we discussed about the size of the colloids. It is very small size, less than 0.001 millimeter or less than 0.1 micrometer. And also, it is we cannot observe this one through the naked eye. We can observe it through the electron microscope. Okay, under the size. And again, under the surface area, so since it is having the small size, so it may have the high surface area. Okay, because of the high surface area, it can call the much of the ions. Okay, at the meantime, since the soil colloids having the negative charges, it may attract the positive charge cations and it forms the ionic double layer. Basically, this is how the colloids behave, right? Now we are going to discuss about the classification of soil colloids. As I said, basically there are two types. One is organic colloids and other one is the inorganic colloids. Okay, this is very important. Please listen carefully, right? I will ask the questions also. So these colloids may be classified into organic colloids and also the inorganic colloids. So this inorganic colloids, this is basically how it is uh, classified is depending on the nature of the linkage. Okay, depending on the nature of the linkage present and also type of compounds formed. For example, if the colloids formed from the parent material, so that is definitely comes under the inorganic colloids. Due to the weathering of parent materials, inorganic colloids formed. So when it forms from the organic compounds, that is definitely comes under the organic colloids. Okay. Again, this inorganic colloids differentiate or mean the categorized into three layers: liquid clays, iron and aluminum hydroxides, okay, and the olefin and other amorphous minerals. Okay, layers: liquid clays, iron and aluminum hydroxide, and then olefin and other amorphous minerals. Okay, again depending on the nature of bonds between these adjacent layers. Okay, so this layers ligates classified into 1:1 type, 2:1 type, and 2:1 type, or 2:2. This is we call 2:1 or 2:2 type. Okay, so under the 2:1 type, again it is depends on the nature of the linkage between the adjacent layers. It is again classified into 2:1 expanding type, 2:1 limited expanding, and 2:1 non-expanding type. Understand?
Yes, ma'am.
Okay. Here we will study about this inorganic colloids now. Okay, before coming to the classification of inorganic colloids, we will see what it is. These inorganic colloids are formed from the weathering of rocks and parent material. Mainly, if it is formed from the weathering of rocks and parent material, definitely these are the secondary minerals. Understand? It is almost forming from the already existing one, right? So it is mainly consist of secondary minerals. So in normal soil, the proportion of inorganic colloids are much higher than the organic colloids. Okay, when you take a normal soil, there you can see the proportion of inorganic colloids are more than the organic colloids. Okay, normally these inorganic colloids are located in the semi-arid, subtropical, and the tropical regions. Okay, so here in this part of the area, so almost all the colloids are inorganic colloids. Okay. Again, these inorganic colloids are categorized into layers ligates, iron and aluminum hydroxide, olefin, and other amorphous minerals. Okay. You all clear up to this? Any doubts? Any doubts up to this? If you have any doubts, you can ask me. Yes.
Layers wicket place were divided three types.
Yes.
One is to one type.
You mean here? Layers
Yes, ma'am.
So because I will explain it, right? Because for the formation of layers liquid clays, there are two layers are important. That is we call it as the building blocks of the this clay minerals. Okay, that is we call that silicon tetrahedral sheet and the aluminum octahedral sheet. Okay, so based on the arrangement of this silicon tetrahedral and the aluminum octahedral sheet, this is again classified 1:1 type, 2:1, and 2:2. For example, if it is made up of the clay mineral is made up of one silicon tetrahedral and one aluminum octahedral sheet, that is we call as the 1:1 type. Definitely, I will explain that one. Right? I will give you the more clarification for your question, right? So I was studying about that part. Okay. Any doubts? Thank you. Any doubts? We don't have doubts, then we can directly move to the each type here. So we can study about it. Yes.
Excuse me, ma'am.
Yes.
Which soil type soil colloids have positive charge and negative charges?
I don't understand. Normally, soil colloids, most of the colloids have the negative charge. Right? Because of negative charge, it may attract the positive cation and it depends on that. It may go for the cation exchange capacity. So because of that cation exchange capacity, plant can take up the nutrients from these colloids. What is the question of you? I don't understand actually the question. Which type of?
Which type of soil colloids have negative charge, and which type of soil colloids have positive charge? Can you differentiate that?
I mean, that is the thing. Almost all the colloids have the negative charge. You are asking about this within this classification. You are asking whether 1:1 type have high negative charge, like
No, ma'am.
then?
No, ma'am. Can I ask one more time?
Yes.
மேடம் இப்போ டிஃப்ரெண்ட் சாயில் டைப்ஸ் இருக்கு தானே, அப்போ அதுல நாங்கள் இப்போ சொல்லலாமா அந்த சாயில் கொலைட்ஸ்ல பாசிட்டிவ் சார்ஜ் இந்த டைப்ஸ் இருக்கும், நெகட்டிவ் சார்ஜ் இந்த டைப் இருக்கும்போது நாங்கள் டிஃபரெண்ட் பண்ண முடியும்.
Exactly. If you know about the soil classification system, you mean you are asking about the soil classification, right? So if you know about the soil classification system, there you have to study what kind of minerals are there, right? So for example, if the soil is dominated by montmorillonite clay, or if the soil is dominated by kaolinite clay, or if the soil is dominated by smectite clay, it is depends on the domination of the minerals there, right? Understand?
Okay, ma'am.
Yeah, it is. If the soil is having, for example, we cannot tell that if the soil is having more negative charge or more positive charge, but we can tell about the properties of soil, right? If, for example, if the soil is dominated by the kaolinite clay, right? So we can tell about the property of the soil, whether the soil is having high cation exchange capacity or how low cation exchange capacity, or high base saturation or low base saturation. What about the water holding capacity of the soil? Such kind of properties we can tell. Understand? Otherwise, almost all the colloidal materials are having the negative charges. Right?
Okay, ma'am. Thank you. Yes, ma'am. Thank you so much.
Now, we'll see about this classification lately. We are going to discuss about the each and every types and the properties of each and every types with the examples. Okay, so we almost started to study about the inorganic colloids. So these inorganic colloids are normally derived from the weathering of rocks and the parent materials. Since it is deriving from the already existing rocks or parent materials, normally this includes the secondary minerals. Okay, and also this is again classified into three types: layers with iron and aluminum hydroxide, and the alophane or the amorphous minerals. Now we see what is the layer liquid. Okay, the one person you ask about what is 1:1 type. So answer is here, right? So these layers liquids are made up of silicon tetrahedral and the aluminum octahedral layers. These are the major building blocks of these layers liquids. Because based on the arrangement of this silicon tetrahedral and the aluminum octahedral, this 1:1, 2:1, 2:2 types are formed. Okay, so the building blocks of the layers liquids are the silicon tetrahedral and the aluminum octahedral sheets. Okay, we will see what it is. What is silicon tetrahedral and aluminum octahedral? We will see, right? So once a question comes about the building blocks of layers liquid place, what would be the answer? Any of you? Any of you? 014. If the questions comes, what are the building blocks of the layers liquids? What would be the answer?
Silica tetrahedral and aluminum octahedral.
Yes, exactly. Okay, so these are the major building blocks of this layers liquids. Now we see what is silica tetrahedral. Okay, here one silicon atom. Can you all see my slides? Are you all looking at slides?
Yes, ma'am.
one silicon ion, right, surrounded by 4 oxygen atoms. Okay, this is we call as silicon tetra. Understand? One silicon atom in the middle, that is by the purple coloring. Okay, and 4 oxygen atoms at the apical sides. So therefore, you can imagine it is having 4-side configuration. 4-side. Can you imagine it? How many sides? How many surfaces there? How many surfaces? 4. 4 sides are there. Can you imagine? In the middle, there is a one silicon atom, and in the other 4 sides, for 4 apical regions, there is an oxygen atom. Can you imagine it? So that is called as the silica tetrahedron. One silicon atom here in the middle surrounded by 4 oxygen atoms. So therefore it is giving 4-side configuration. Okay? Here, I will show you that. Here you can see. Now understand? 4 sides, one side, second side, and third side is there behind that, another side, 4 sides. Understand?
Yes, ma'am.
Yes, ma'am. Yeah, these are the 4 apical oxygen. One is here. Once you look at my slides only, you can understand. Okay, here is the one oxygen and second oxygen, third oxygen, fourth oxygen. In the middle, you cannot see that there is a silicon atom. Okay, so understand what is silicon tetrahedron. One silicon atom is surrounded by 4 oxygen atoms and giving 4-side configuration. That is we call as a silicon tetrahedron. So here an introduction arrangement of series of tetrahedron tied together by a shared oxygen atom giving the tetrahedron sheet. This is the one silicon tetrahedron molecule, right? So while joining these other silicon tetrahedron, several silicon tetrahedron sheets, it formed the silicon tetrahedron sheet. Here you can see one silicon tetrahedron by joining with other silicon tetrahedron by the oxygen ring. Here, by sharing the oxygen, it join. Understand? So that is how here it's formed by joining the oxygen in the apical portions. So it forms a hexagonal rings-like structure. So polyhedral here. This is how the silicon tetrahedral sheet is formed. Understand? By sharing the oxygen atoms in the apical part. This is how the silicon tetrahedral sheet is formed. Understand now? Any doubts? What do you mean by silicon tetrahedron? Any of you? What is silicon tetrahedron?
One silicon atom is surrounded by 4 oxygen atoms.
4 oxygen atom and giving how many side configuration? 4 side. Just imagine, then only you can understand it. Otherwise, it is not much easy to understand, right? This is how the tetrahedral sheet is formed by sharing the oxygen in the apical portion, right? The aluminum octahedron. Why we are looking at this silicon tetrahedron and aluminum octahedron? Because this is the basic molecules to form the rare silicate minerals. Okay, so see the aluminum octahedron. Here, one aluminum is surrounded by 6 oxygen atoms or OH minus groups. Here you can see the 8-side configuration. I'll show you. Here you can see one aluminum atom in the middle. You cannot observe that one here. So here 6 oxygen. 1, 2, 3, 4, 5, and 6. Understand? Understand? 1, 2, 3, 4. See, you just take one octahedral shape and see. This is a linkage, but without linking these two, you just observe one. 1 oxygen, 2 oxygen, 3 oxygen, 4 oxygen, 5, and in the bottom 6. Again, the same structure in the bottom. Then 6 oxygen, and in the middle, 1 aluminum. Understand?
Yes, ma'am.
This is the polyhedral view, how it is joining by other octahedral sheet, and how it forms the octahedral. Okay, yeah. So in the aluminum, in this portion, this may be substituted by iron, aluminum, mangan, and the magnesium. Okay? Normally, we consider about the magnesium and the aluminum. Okay? Here also an interlocking arrangement of the series of aluminum octahedron is tied together by sharing the oxygen atom by giving the octahedral sheet. Here you can see by sharing the oxygen atom, this one and this one sharing the oxygen here and forming the sheets like structure. Understand? Understand?
Yes, madam.
Okay. This is the linkage here. Okay. And here again, if this octahedral sheet is dominated by the aluminum, that is we call as a dioctahedral, because 2 aluminum ion is enough to satisfy the same negative charges. Therefore, it is called as the aluminum. If it is dominated by aluminum, that is dioctahedral. If it is dominated by magnesium in the middle, that is we call as a trioctahedral, because 3 magnesium is needed to satisfy the net negative charge. Okay, so now you are clear about the silicon tetrahedral and the aluminum octahedral. Silicon tetrahedral means, again I'm telling, so one silicon atom is surrounded by 4 oxygen atom and giving 4-side configuration. Okay, here. And then aluminum octahedral means 1 aluminum atom surrounded by 6 oxygen or OH minus and giving the 8-side configuration. Imagine once it joined with the 6 atoms, it may give you the 8-side configuration. One, yes, you can say 1, 2, 3, 4. Again, in the bottom, there are 4 sides. So together, 8-side configuration. Okay. So if this octahedral sheet is dominated by aluminum, that is we call as a dioctahedral sheet. If it is dominated by magnesium, that is we call as a trioctahedral sheet. Okay? Because 2 aluminum ions in the dioctahedral sheet satisfy the same negative charges from the surrounding oxygen or the hydroxy group as 3 magnesium ions in the tetrahedral sheet. Trioctahedral. Okay, that is the trioctahedral. Understand? So these tetrahedral and octahedral are bound together within the crystal units by shared oxygen atoms into different layers. Okay? Are you all clear about the building blocks or the basic molecules of the layers liquids? What is silicon tetrahedral and aluminum octahedral, and what is dioctahedral and what is trioctahedral? Understand? Any doubts? Any doubts? Boys, any doubts you want to ask? Anything you want to clear? Are you all okay? Anyone please tell me. Then only we can move to the next slide. Are you all hear me?
Yes, ma'am.
Yes, ma'am.
Any doubts? Is it clear for you?
Yes, ma'am. Yes, ma'am.
Any others?
Yes, ma'am.
You can, yes. You can ask me the questions, right? If you have any doubts, you can ask me, feel free. I'm ready to answer, right? This should be the interactive lectures, right? You also should talk, Right. Now we see how this 1:1 and 2:1 types are formed. Right? The person who asked the question about 1:1 and 2:1. Are you there?
Yes,
Are you
ma'am.
there? Okay,
Yes, ma'am.
good. Right. Now we'll see how these 1:1 and 2:1 types are going to form. Right here, first we see how this tetrahedral and the octahedral is going to join, connecting the tetrahedral and the octahedral building blocks to form the planes of silicon and aluminum ions that alternate with the planes of oxygen and hydroxy ions. Normally, how this forms is here you can see again. This is the tetrahedral one. This is the silicon atom, and it is joined by the four oxygen atom. This is the aluminum, and formed joined with the six oxygen and form the octahedral sheet. Here the single units are there. So then it forms by sharing the oxygen or the OH minus. Here again, see, this is the silicon. Anyone tell me, please, silicon?
Tetrahedral.
Tetrahedral. Okay, here, once clearly observe it, right? One silicon atom is here. Is it visible?
Yes, ma'am.
Visible? Yes. One silicon atom is there. 1, 2, 3, 4. Four oxygen atoms. So this is the one molecule of silicon tetrahedral. Okay. Here again, see, this is the aluminum, and here, see, this is very clear, right? The single unit. So one aluminum and 1, 2, 3, 4, 5, 6 oxygen or OH minus. Okay. So this oxygen join with this silicon. This aluminum tetrahedral join with this silicon aluminum octahedral join with this silicon tetrahedral by sharing this oxygen or the OH minus with this silicon. Okay, this is how these two layers are joined. Understand? Understand? Here again, the silicon tetrahedral unit joined by sharing this silicon with this oxygen. Understand?
Yes, ma'am.
Clear? Clear? If not, please tell me. I can explain it more. Shall I? Yeah, this is the single unit of silicon tetrahedral. This is the single unit of aluminum octahedral. So this is here. Just replace this one here. Silicon is there, oxygen and free oxygen. This is the molecule. This silicon is again joined with this aluminum octahedral. Here you can see 1, 2, 3, 4, 5, 6. In the middle, there is an aluminum. Okay, by sharing this oxygen with this silicon, these two layers are joined together. Understand now? Understand now? So here in the middle, this is the silicon plane. Okay, in the middle, this is the silicon plane. This is the oxygen or the OH minus plane. This is again aluminum or the magnesium plane. If it is trioctahedral, 2 magnesium, and if it is a dioctahedral, it is dominated by the aluminum. That is how this is the aluminum and the magnesium plane. Again, the oxygen, and again this is silicon plane and oxygen plane. This is how this is the tetrahedral sheet joined with the octahedral sheet. Understand? This is the one layer. Okay? Understand?
Okay.
So now you know how the silicon tetrahedral and the aluminum octahedral are joined together to form the layers. Okay? Now we see what is 1:1 type. Okay? What is 1:1 type? I think now your time up, right? 1:30, no? Are you all hungry? Shall we discuss about the 1:1 type and finish, or shall we discuss in the next class? Tell me, any of you, is it okay to discuss now or in the next class?
Next class.
Next class. Is it difficult to understand? Any others? Your opinion? Shall we discuss today or in the next class?
Next class, ma'am.
Next class. Next class, okay. So, what about today's lesson? Is it difficult to understand or easy to understand? The subject is somewhat difficult to understand, but if you understand, it's very interesting. Very interesting, right? If you understand yourself, you can go through the internet even. You can get a more clear pictures about this. Once you can get the aluminum octahedral, dioctahedral, trioctahedral shapes, and how it is formed, and how the planes are formed, and how the shapes are developed. You can go through the internet as well for your more clear, the understanding, right? So how was the lesson today? Please give me the feedback whether you need to, whether I need to explain more about it, or is it clear for you all? Tell me. Understandable for all others? Okay. Anyhow, I will ask the questions so far that I have taught you in the next class, right? I hope that you got your notes or you jot down some points there. So based on that, I will ask some questions in the next class, and we will start to discuss about the types of layer slip gates in the next class, right? Okay.
Okay, ma'am.
Thank you.
Thank
You
you.
can
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
you, ma'am.
Thank you, ma'am.
Thank you, ma'am.